Okay, so hello everyone. My name is Kunal and I'm your mathematics tutor. And we are doing actually differential equation. And today is our lecture number 2. So let me recap the thing कि हमने अब तक क्या-क्या cover करी है. So we actually know the definition of differential equation, actually what it is, definition of ordinary differential equation, definition of partial differential equation, and then we get some idea about order and degree, and then we learn how to form a differential equation. So मैंने आपको previous class में कहा था कि first we will deal with some problem, and in today's class we are gonna learn how about the solutions of differential equation. हमने previous class में ऐसा समझा कि differential equation बनाते कैसे हैं, and आज 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 हमें बना बनाया differential equation मिलेगा. So we have to find its solution. But first we will deal with some problem based on formation of differential equation. Okay. So let's begin some problem. So our first question is something look like, let me take here as an example. So it's something look like y is equal to a e to the power 3x plus b e to the power minus 2x. So as you see here, our a and b are the arbitrary, right? So what you have to do, because there is no other way to remove that arbitrary by manipulation, है ना? So actually हमने एक set of rule for और rule of process पढ़ा था कि हमें जो जो अपना मेन टारगेट है ना, वो हमारा ये है कि अपन को जितने भी आर्बिट्रेरी कांस्टेंट है ना, जितने भी आर्बिट्रेरी पैरामीटर्स हैं, हमें उन्हें रिमूव करनी, दैट्स इट. सो एक्चुअली सिंपल मैनिपुलेशन यहाँ पे कुछ कर भी नहीं सकते. सो व्हाट इज द वे लेफ्ट इज, so the way left is just differentiate it. So it will be like 3a to the power 3x minus 2b to the power e to the power minus 2x. Again differentiate it. So y double is equal to 9a to the power 3x plus 4b e to the power minus 2x. Now you have to use these three equations. You have to use this three equation to remove our arbitrary parameter. Okay, so you have to use this these three of the equation. So how can we do this? So just solve, and we have to find the value of e to the power 3x and e to the power minus 2x. Okay, so and just we have to put in the equation term. So actually what we will get as, so let me tell you one thing. Let me tell you one thing. This is like a e to the power 3x is equal to y plus y dash divided by 5. So when you solve this three equation, so you will get. Now the question is how do you solve? So it's easy now, like take the coefficient. This is 1, this is 2, right? Let me write it here. So we can solve this as like a plus b is equal to y, and 3a minus 2b is equal to y dash, and y double dash is equal to 3a plus 4b. है ना? We just take e to the power a e to the power 3x as some constant as big capital A and capital B, and then solve the equation to calculate the value of a, and so you will get this final answer. Okay, I hope you'll all understand this what I'm trying to say. Now the next question is something look like मैंने आपको पहले भी कहा था कि we will deal with some word problem kind of thing. So अपन वो भी कर रहे होंगे. So first try to form the differential equation. So let me tell you, I hope you will deal with some conics section. So actually we are going to use the concept of conic section. So next our example will be, it's actually based on word problem. So let me write a form the differential equation of the family, form the differential equation of the family of the hyperbolars having foci. Foci means that's a pair of the focus, right, on x-axis and center at the origin. So actually मैंने geometrical interpretation बताया था कि ज्योमेट्रिकल इंटीग्रेशन में बताया था कि द डिफरेंशियल इक्वेशन एक्चुअली रिप्रेजेंट द फैमिली ऑफ ए कर्व्स व्हिच हैव सम कॉमन इन प्रॉपर्टी, है ना। बेसिकली क्या होती है कि कुछ प्रॉपर्टीज होती है ना वो कॉमन होती है, एंड इट्स अ फैमिली ऑफ कर्व। सो यू हैव टू फॉर्म अ डिफरेंशियल इक्वेशन विच इज द फैमिली ऑफ अ हाइपरबोला जिसकी फोकस जो होगी वो एक्स एक्सिस पे होगा, and its center is at all. So our hyperbola is something look like if we draw the figure, this is our x-axis and this is our y-axis, and this is our something hyperbola is because this is our this is actually the center of the hyperbola which is at origin, and the focus which is obviously we know that c into epsilon hoti hai na? So I'm not gonna write that a into epsilon comma 0, and this is like minus a into epsilon comma 0. I hope you all know this kind of thing. And the equation of hyperbola is nothing but x square by a square minus y square by b square is equal to 1. So this is our given equation. So actually, and there is two arbitrary parameter, which is a and b. So our main target is to remove this arbitrary parameter, है ना. So let's try to do, because they कोई simple manipulation करके कुछ होने वाला नहीं यहाँ पे. So let's try to just differentiate it. So when we differentiate this is our actually equation of hyperbola. So differentiate it. So when we differentiate the equation of hyperbola, so what we get actually 2x by a 2x by a square minus y dash 2y dash by b square is equal to 0. So what we will get from here, actually we will get from here like x by y dash is equal to a square by b square. And this is our nothing but equation number 1. Now, now differentiate one more times, right? So we can get some a good value, because देखो यहाँ पे arbitrary एक side आ गई ना. So when we differentiate it one more time, uh, the differentiation of the right hand side will be 0. Okay, the differentiation of the right side will be 0. So let's try to differentiate one more time. So differentiate one more time. So when we differentiate it, what we will get? Just try to differentiate it. So we will get 2 by a square. We are actually differentiating this. So 2 by a square minus b square, and we are going to differentiate y dash. So it will be y dash square plus y into y double dash. We write it into bracket. Otherwise, it seems as y to the power 12 is equal to 0. So what we will get from here? We will get from here is 2 by a square is nothing but 2 y dash square plus y double dash and divided by b square. So we will get 2 by y dash square plus y double dash, I mean double differentiation, equal to a square by b square. Now let's put the value of a square by b square in equation number 1. So put the value of a square by b square in equation number 1. So what we will get? We will get x by y dash is equal to 2 by y dash square plus y double dash. So this is actually our differential equation of the family of hyperbola जिसकी focus जो है वो कहाँ पे है? x axis पे है, and जिसकी center जो है वो origin पे है. So it seems like this. Okay, so actually यही करना था भाई. Now let's take one more word problem. Then we move to the other topic, which is actually the solution of differential equation. So let's take one more topic here. Let something look like this question. Which of the following differential equation? Let me take it here. Okay. So our question is something look like form a differential equation of a family of parabola whose axis of symmetry is parallel to the x-axis. Okay, so you have to form a differential equation of the family of a curve, and the curve is actually parabola whose whose axis of symmetry is actually parallel to the x-axis. Okay, so we all know this the formula of the parabola whose axis is symmetric to the whose axis is parallel to the x-axis. So we all know that. So let's try to write it here. The actually आपने कोने से ना पढ़ रखा हो, so I'm using here directly. So it will be like actually x-axis के parallel है ना, whose axis of symmetry is something parallel to the x-axis. So it will be something like this. It can be any parabola. So we are actually using its center as h comma k. We can use here, है ना? And then we try to look at here. It's this is the axis of the parabola. This axis is parallel to the x-axis, है ना? ये जो axis है ये x-axis क्या है? Parallel. So its equation will be equation of such a parabola will be equal to actually y minus k square is equal to 4a into x minus h. Imply we can write this also as x is equal to ay square plus something by plus c. So now here capital A and capital B are arbitrary parameter of above equation, right? So what you have to do, we are gonna start. And one more thing, A, B, and C is 2, right? So let's try to solve this. So what I'm gonna do here is differentiate, because there is that there because देखो यहाँ पे मैनिपुलेट करके कुछ होगा नहीं ना, क्योंकि ए बी सी जो है वो इम्प्लिसिटली कनेक्टेड है ना, तो कुछ कर नहीं सकते. तो देखो मैनिपुलेशन वहां पे नहीं लगा सकते जहाँ पे आर्बिट्रेरी पैरामीटर्स जो है ना वो इम्प्लिसिटली कनेक्टेड हो. ठीक है, तो कुछ कर ही नहीं सकते वहां पे. जहाँ पे एक्सप्लिसिटली कनेक्टेड है आर्बिट्रेरी पैरामीटर, तो वहां पे कुछ करी जा सकती है. ठीक है, सो यहाँ पे कुछ नहीं कर सकते. सो जस्ट डिफरेंशिएट दिस इज आवर बेसिक इक्वेशन. सो डिफरेंशिएट द इक्वेशन वन. So what we will get? We will get 1 is equal to 2ay y dash plus by dash. C will be 0. Okay. So finally we remove, after differentiating it one times, we finally remove the first arbitrary parameter, which is actually C. Now differentiate it one more times. But यहाँ पे एक second, यहाँ पे we can say one more thing. Our y dash is equal to, if we take y dash as common, so what we will get? We will get 1 by 2ay plus b. So this is actually our y dash. Now differentiate one more times. Differentiate it one more times. So what we will get here? This will be counted as 0, and we will get 2a. Differentiate this. So what we will get? Y dash square plus, and there will be we get y into y double dash. Okay. Here we'll get y double dash. Right. So try to simplify it, and okay, and then see what we can do. or otherwise try to differentiate it one more times. That will be one more fine. So differentiate it one more time. Let me erase it here and differentiate it one more time. So differentiate it one more time. So what we will get? We will get 0 and there will be like 2a, and when we differentiate the y dash square, so what we'll get 2y dash and then y double dash, and then we have to differentiate this. So what we will get? Y dash y double dash plus y triple dash, and there will be by ट्रिपल डैश एंड हमने इसको बताया था कि y ट्रिपल डैश का मतलब क्या है dq y by dx cube. now now what you have to do, just try to put the values. Okay, so like it will be clear. So here we can write 0 is equal to minus b minus b y dash y double dash divided by y dash square plus y into y double dash. So what we will get here? We'll get 3y dash y double dash plus y dot y triple dash, right? So what I'm gonna do here is, and plus b y triple dash is left. I'm just calculating. So I want to suggest you like do calculation by own, so it will be more clear to you. So this b and b get cancelled because opposite side is 0. So what will get? Minus 3y dot the y double dash square minus y dot y double dash dot y triple plus y triple dot y. I'm just multiplying it here, right? And plus y dot y double dot y triple dot. So this will get cancelled. So what we will get as finally, we will get as 0 is equal to minus 3y double dash square plus y triple dash dot y. So this is our difference. So this is our actually differential equation of parabola whose axis is parallel to x-axis. Okay. Okay. And there is a noted point. The order of a differential equation is equal to the number of arbitrary constants present after minimizing. I hope मैं ये लाइन मैंने पिछली क्लास में भी लिखी थी. So I'm writing again to try to मतलब अच्छे से समझ में आ जाए. That's it. Okay. So now I'm gonna write one more thing like some important theory part. So let me write it here. So let me write it in a box so you can. This related to something conic से अपन relate कर रहे होंगे. So okay. Okay. So here the first point is a line is a two parameter, right? Like y is equal to mx plus c. So there will be two parameter m and c. So two parameter of family of curve. This thing you have to like तो इसकी डिग्री कितनी हो जाएगी, ऑर्डर कितनी हो जाएगी, 2 हो जाएगी. A circle has 3. Let me write it here. Circle has 3 parameter. बाकी आगे ये रिपीट हो रही है. Third thing, a parabola. Parabola has a 4 parameter of है ना. And the fourth thing is like ellipse and hyperbola. Ellipse and hyperbola is a 5 parameter. आगे वही. And fifth है the rectangular hyperbola. I hope you all know this. So the rectangular hyperbola is something either this or this. Actually, this is known as rectangular hyperbola. Okay. So rectangular hyperbola is its equation like x y equal to c square. Okay. So yeah, rectangular hyperbola is a 4 is a four parameter family of curve. Okay, so these 5 points you have to keep in mind during uh, during finding the differential equation, right? Like how to form differential equation. अगर आपको कोई भी कहा जाए like सर्कल का बनाओ या लाइन का बनाओ तो उसमें पता होना चाहिए कि इसमें 2 पैरामीटर और फैमिली ऑफ कर्व्स होती है. Okay, so now let's move on to the uh, our today's new topic, which is something is a solution of differential equation. Okay, so let's try to learn this. So actually, we are going to start our new topic. So let me write it here with a. Okay, so it is actually solution of differential equation. हमने ये देख लिया कि एक्चुअली डिफरेंशियल इक्वेशन बनाते कैसे, हाउ टू फॉर्म द डिफरेंशियल इक्वेशन, एंड नाउ वी आर गोइंग टू लर्न द सॉल्यूशन उसकी जो भी हमने बनाया है. लाइक यहाँ पे जो भी हमने डिफरेंशियल इक्वेशन हमने बनाई इसकी सॉल्यूशंस क्या है. लाइक यहाँ पे बनाया हमने इसकी सॉल्यूशंस क्या है, इसके ऊपर ही बनाया है इसकी सॉल्यूशंस क्या है ना. सो वी आर गोना लर्न दिस थिंग. सो आवर फर्स्ट सॉल्यूशन इज बाय नोन बाय जनरल सॉल्यूशन. So what a general solution is? So let me try to give its definition first. So a solution obtained by solving differential equation actually contains number of arbitrary parameter equal to order of a differential equation. So let me write it here, which contain a number of arbitrary parameter equal to order of the differential equation. Now the second thing is a particular solution. So what is actually particular solution is? So let me try to give a definition first, and then we are learning how what is actually. So a solution obtained from general solution. Obtained from general solution is called singular solution, or in some cases, right, is called, maybe it's called singular solution, or maybe it's called particular solution as well, right? So this is the definition. So basically, a general solution, which is will get by solving the differential equation, uh, which contains the number of arbitrary parameter equal to the order of differential equation. And the second is particular solution. So a solution which obtained from the general solution is called particular solution. Okay, so ये तो हमने देख लिया कि solutions of differential equation. Now there is a method, right? Like so we are gonna learn now method of finding the solution of differential equation. So let me write it here. So method of finding the solution of differential equation. Okay, so let me write it here. The first method is called variable separable. Variable separable method. Okay, so it will be like variable separable method. So let me write here. If a differential equation of order 1, okay, if a differential equation of order 1 and degree 1 can be expressed as dy by dx is equal to fx by dx, fx by gy, and then what we do gy dy is equal to fx integration of fx dx, and we will get a solution. So this is the basically variable separable method is only applicable when the order and the degree of differential equation is 1. Otherwise it is not applicable. Okay, so first we will have to see the case which have degree and order 1. And if the degree and order is 1, so what you have to do is you have to actually write dy by dx as uh, fx by gy, and then just integrate by taking uh, the function with its respective elementary element, right? So let me take an example. So let's practice some problem in variable separable. Okay, so let's take our example number 1. So this is actually a basic theory, so you have to uh, go through it. And बस जो भी ऊपर लिखी है उसको follow करनी है. So this is example number 1. Our question is x plus y dy by dx is equal to 0. So look at here. Actually, this is actually differential equation because it has derivative part. It has some variables which is dependent and which is independent, right? So and there is no arbitrary. So this is a differential equation, and now you have to find the order and the degree. So its order is, look at here. It's a power. It is the first derivative, right? So its order is 1. And जो highest order है उसकी power कितनी है? It is also 1. So degree is also 1. So we can apply here variable separable. So what we have to write? We have to just write dy by dx into the form of x by y and y by x, whatever. So we get y dy by dx. Take the x on the right hand side. So we get minus x imply dy by dx is equal to, what we'll get here? Minus x by y. Now what you have to do? You have to cross multiply here and just integrate both sides. So do the cross multiplication here. So what we will get from here? Y dy and is equal to minus x dx. And then what you have to do? Integrate both side. Hana? So what we will get? Integration of y dy is equal to integration of minus x dx. So what we will get here? We will get y square by 2 is equal to x square by 2 with the negative sign, right? And यहाँ पे लिख देते हैं open some negative and some constant we get, right? Because it's an indefinite integration. So we will definitely get constant because we are not substituting any kind of limit here, right? So its integration will be definite. So we will get some constant here also. And then just proceed on here. So what we will get here? We get x square plus y square by 2 is equal to k. So here we will get x square plus y square is equal to 2k. So actually this is our solution. X square plus y square is equal to 2k is the solution of differential equation, which is actually written as x plus y dy by dx is equal to 0. ये हुआ एक. ठीक है. सो फर्स्ट यू हैव टू, कैसे करनी है प्रॉब्लम, तो आपके पास ये डिफरेंशियल इक्वेशन दी हुई होंगी. फर्स्ट यू हैव टू फाइंड द ऑर्डर एंड डिग्री कि क्या है. अगर ऑर्डर एंड डिग्री is 1, look at here, variable separable. If a differential equation of order and degree 1, then only it apply. Otherwise we can't apply this method. We learn some new method and then we apply that. But first you have to uh, identify the order and the degree of a differential equation. If the order and degree is 1, so then write dy by dx independently as something function by fx by gy, and then try to integrate both sides. So we will get the solution of the differential equation. Okay, so I think it will be clear to you. So let's take one more example. So our So our new example is something look like question 2. It will be something like y plus x dy by dx is equal to 0. So you have to find the its basically solution. So what it will be? So look at here. First step we have to get its order and degree. Order and degree. So what is the order of? Let me raise that right in a clear way. So what is the order of the above differential equation? So the order of above differential equation is 1 because it is actually first derivative and the max power on the first derivative is also 1. So degree is also 1. So we are free to use variable separable variables. So what you have to do? I have to just write dy by dx as independent. So dy by dx is equal to x, dy by dx is equal to minus y. So implies here we get dy by dx is equal to minus y by x. I hope this thing will clear to you, right? So we will get dy by dx is equal to minus y by x. Now what you have to do? I have to just integrate by taking same kind of function one side. So what we will get here? We'll get dy by y is equal to minus dx by x. And then integrate the both side, integrating both side. And we all know that the integration of 1 by x dx is nothing but ln mod x. So in left hand side, we'll get ln mod of y. And in right hand side, we get ln mod of x. It's plus some constant. From now on, what we gonna do here is uh, take that take this as a left hand side. So what we will get? Ln mod y plus ln mod x is equal to some constant c. And this implies ln. We can apply here the basic formula, basic property of logarithm. It will be like ln a plus ln b is equal to ln of ab. It will be like mod of xy is equal to c. And if our constant c is of kind like ln k type ki hai, so our equation, so our solution will be xy is equal to k, and therefore our solution of differential equation y plus x dy by dx is equal to 0 is xy is equal to. Okay, so this is the thing that I wanna you have to use actually. Okay, now let's move on to the next problem. है ना? So actually अभी हम सीख क्या रहे हैं अपन, जैसे देखो हमने डिफरेंशियल इक्वेशन बना लिया, अब उसकी सॉल्यूशन निकालेंगे। उसके सॉल्यूशन के बारे में जैसा डेफिनेशन वगैरह पढ़ लिया कि एक जनरल सॉल्यूशन होता है, एक पार्टिकुलर सॉल्यूशन होता है, तो वी आर फाइंडिंग द पार्टिकुलर सॉल्यूशन। नाउ द थिंग्स इज कि अब मेथड होगी ना उसकी सॉल्यूशन निकालने की। तो पहली मेथड अभी अपन पढ़ रहे हैं वेरिएबल सेपरेबल मेथड, जो कि कब एप्लीकेबल होती है? जब अपनी डिफरेंशियल इक्वेशन की ऑर्डर एंड डिग्री 1, right? And we were doing actually practicing and actually we are doing some problem. Okay, so let's move on to the problem number 3. Okay, so it will be something look like जब यहाँ पे दिया ही हुआ है dy by dx is equal to a to the power x plus y. So my suggestion is to pause the video and try to solve it by own. And अगर नहीं होता है then watch the solution because it's an easy part because look at here the order clearly visible ना कि order is 1 and degree is also 1 है ना? Now dy by dx को यहाँ पे इसको क्या लिख सकते हैं? By using the simple exponential property, what we can write is this as e to the power x into e to the power y, and now you have to take the same function as one side, so it will be dy by e to the power y and e to the power x dx. And now what we can write? E to the power minus y dy. e to the power x dx. And now what you have to do, integrate both sides. So what we will get here, we will get from here is minus e to the power minus y oh, is equal to e to the power x plus some constant, right? So what do we get from here? What we'll get e to the power x plus 1 by e to the power y plus some constant is equal to 0. And so therefore, e to the power x plus 1 by e to the power y plus some constant is the solution of differential equation, dy by dx is equal to e to the power x plus y. Okay, so this is the thing that we have to show about that. Now let's take a board problem or something kind, like we are calculating some limit, some constant value as well. So let's try to solve this question. Next question. Next question is a little bit. We have to do one more step. Just we have to find the constant value, right? So let's move on. Okay, so our problem is something look like fourth number. E to the power y dash, I mean e to the power dy by dx, okay, is equal to x. And the value of phi 1 is 1 given. Find the particular solution. These were actually general solution, right? We are now finding the particular solution because we have to find the constant as well. Okay, so let me try to write it here. So take the log both sides. So what we will get? We will get y dash equal to ln of x. And we can write dy by dx as log of x, right? Now let's try to find it out as its order and degree. So yeah, its order is 1 and degree is also 1, right? So order is 1 and degree is also. Now we have to integrate. So we have to integrate dy ln x dx and integrate. Okay, so now integrate. So when we integrate this both sides, so what we'll get? We all know the integration of ln x as nothing but x of ln x minus 1, right? So there will be y is equal to x of ln x minus 1 plus some constant. Now here, now I actually have to find the particular solution, right? So for the particular solution, what we have to do actually, we have to put some value, like, so here is something given, which is actually, look at here, at x is equal to 1, y value 1. So at x is equal to 1, actually, let me erase and write it in a clear way. Actually, there is something given y1 is equal to 1. That means at x is equal to 1, y value 1. So let's try to put it here. The value of x is equal to 1. So when we put that, we will get 1 is equal to 1. This will get 0 and minus 1 and plus 2. So the value of k will get 2. So our particular, so now y is equal to x of ln x minus 1 and plus, what is the value of k here is 2. So y is equal to x ln x minus 1 plus 2 is the particular solution for the differential equation e to the power y dash is equal to x. Okay, this is actually the particular solution, right? So I think this will be clear to you. Now let's move on to the one more problem, and in this problem also we have to find the particular solution. So the fourth problem is something look like 1 plus e to the power x into y into dy by dx is equal to e to the power x and there's given like y0 is equal to 1. Okay. Find its particular solution. So look at here. First order is 1. All right. And now we have to find the degree. So the degree of differential equation given is also 1. Okay. So we can apply the variable separable method here. So now what we have to do, we have to write the dy by dx as e to the power x y 1 plus e to the power x. Now we have to take the same form of same side. So y dy equal to e to the power x plus 1 plus e to the power x and dx. And now what you have to do, we have to just integrate both sides. Now look at here. If this is our f, so this is our df. So what is the integration of f by df? Nothing but ln of f. So it will be get y square by 2 is equal to ln of 1 plus e to the power x and plus some constant we get, right? So actually we get this thing y square by 2 is equal to ln 1 plus e to the power x plus some constant. So now we have to find the value of k. So now there is one thing is given, y0 is equal to 1. So as y0 is equal to 1 given, so what you have to do, put the value of x is equal to 0 here. So we'll get the solution 1. So 1 by 2 is equal to 1 by ln of 2 plus k. So take that right side. So what do we get? 1 by 2 minus ln 2. This is our k value. Now the y square by 2 is equal to log of 1 plus e to the power x plus the value of k is 1 by 2 minus ln. This is actually particular solution, right? And okay. So when we solve this, basically, so what we will get y square is equal to, we are using just a simple logarithmic property. So 1 plus e to the power x by 2 whole square plus 1. So therefore, y square is equal to ln 1 plus e to the power x by 2 whole square plus 1 is the particular solution for our given differential equation, which is 1 plus for 1 plus e to the power x into y into dy by dx is equal to e to the power x. This is our actually solution. So let me erase it for differential equation. So okay. So I hope in today's class you all understand what is actually particular solution and general solution. So आज के क्लास हमने क्या सीखा? Let me recap one thing. तो आज की क्लास हमने पहले वर्ड प्रॉब्लम करी बाय फाइंड टू लाइक हाउ टू क्रिएट डिफरेंशियल इक्वेशन एंड अब हमने जब डिफरेंशियल इक्वेशन बना लिया, ठीक है, सो वी आर गोना लर्न अबाउट द सॉल्यूशन ऑफ डिफरेंशियल इक्वेशन कि कैसे सॉल्व करते हैं, सो क्या क्या होता है, विल बी जनरल सॉल्यूशन एंड द पर्टिकुलर सॉल्यूशन and then we are actually going to learn ki what are the methods of finding the solution of differential equation. So first will be variable separable method. So वो कब लगाते हैं? तो it has a fixed condition. So the only condition we applied variable separable is कि जब differential equation की order and degree वन हो, so we can apply here. And हमने उसमें practice भी कर लिया. So in tomorrow class, we are going to learn some new method of solving differential equation, right? To get its solution, general as well as particular, right? So, okay, that's all for today's guys. I hope you'll all learn something new thing in differential equation. So, okay, thank you. We will meet in next class.